Hello everyone, I am Orlin Abelog and welcome to my video on number systems. Today, I will explain and demonstrate how to convert between different number systems. Binary to decimal, decimal to binary, decimal to octal, decimal to hexadecimal, and hexadecimal to binary. Okay, let's start it. The conversation, let's briefly understand what these number systems are. Binary. Binary is base 2. It uses only two digits, 0 and 1. Computers use binary because they work with on and off signals. Decimal. Decimal is base 10. This is the number system we use every day with digits 0 to 9. Octal. Octal is base 8. It uses digits from 0 to 7. Hexadecimal. Hexadecimal is base 16. It uses digits 0 to 9 and letters A to F, where A means 10, B means 11, and so on up to F, which means 15.
So let's start with this example 1010. So how can we convert these particular binary numbers, which is a base is 2 system? So the digits can only be 0 or 1. How can we convert it into a decimal number? Now, the first value is 2 to the 0 power. And the second one is going to be this number times 2 to the first power. And the third value going from right to left is 0 times 2 squared. And this one is going to be 1 times 2 to the third power. So 1 times 2 to the third power, that is equal to 2 to the third power. Then if we multiply 2 squared by 0, that's going to give us 0. And we're going to add these values. So 1 times 2 to the first power is equivalent to 2 to the first power. Then 0 times 2 to the 0 is 0. So everywhere you see a 0, you could ignore it, because all the value that can be multiplied by 0 is equal to 0. So we only need to focus on the numbers that contain 1. Now, let's add up these numbers. So let's start with 2 to the third power is equal to 2 times 2 times 2 is equal to 8. So, let's put the 8 here, plus, because 2 to the first power is equals to 2, then 8 plus 2 is equal to 10. So the binary number of 1010 has a value of 10. So we must all remember that binary numbers is power all digital devices. They simplify complex data into zeros and ones, enabling fast and reliable computing. Without binary numbers, modern technology and communication wouldn't exist. So let's try another example, which is 10010. So let's start from the right side. This is going to be the 2 to the 0 power, and then 2 to the first power, and next is 2 to the second power, then next is 2 to the third power, then next is 2 to the fourth power. So we don't need to worry about the zeros, so let's just ignore it. So let's focus on a number that contain 1. So it's gonna be 1 times 2 to the fourth power, then it's equal to 2 to the fourth power. Then 1 times 2 to the first power is equivalent to 2 to the first power. So the zeros must be ignored because all 0 that multiplied into a value is equivalent to 0. And to start with 2 to the 4th power is equivalent to 2 times 2 times 2 times 2 is equal to 16. While on the 2 to the 1st power is equal to 2. Then definitely 16 plus 2 is equal to 18. So the binary number of 10010 has a value of 18. So always remember that converting binary to decimal is important for understanding computer data, programming, digital electronics, and simplifying human interpretation of binary coded information. So in the next video, we're going to talk about how to convert decimal numbers into binary numbers. So how we can convert 75 into binary number? So it helps to be familiar with the powers of 2. So 2 to the 0 power is 1, 2 to the 1st power is 2, 2 to the 2nd power is 4, 2 to the 3rd power is 8, 2 to the 4th power is 16, 2 to the 5th power is 32, 2 to the 6th power is 64, while 2 to the 7th power is 128. So we don't need to go further because 128 exceeds 275. So the highest number that is highest base 2 number that is less than 75 is 64. So we're going to start with 64. So in this video, I'm going to show you how this subtraction method is converted into decimal numbers into binary numbers. Now, once you have your first number, which is 64 in this case, let's subtract 75 by 64 is equal to 11. So the highest number that under in 11 is 8. And 16 exceeds 11, so we can use that. Then let's put 8 here. Then we're going to subtract by 11 by 8 is equal to 3. So the next highest number just under 2, 3 is 2. So let's put 2 here. Then 3 minus 2 is equivalent to 1. So the next highest number is 1. So we could stop here. Because if you add these numbers, 64 plus 8, that's 72. Then 72 plus 2 is 74. Then 74 plus 1 is equal to 75. So these 4 numbers add up to 75. Now, once you have that, you can begin to write the numbers in binary numbers. So we have 64, we're gonna put 1, then 32, we have no 32, so we're gonna put 0, then 16, we have no 16, so definitely going to 0, and we have also 8, then we add 1, then 4, we have no 4, then it's 0, then we have 2 and 1, though it's definitely we have 1, 1. So 75 is equal to 1001011.
Now, here's another example, 142. So, let's write the list of numbers that we're going to work with. 128, 64, 32, 16, 8, 4, 2, 1.
Highest number that under to 142 is what we call the highest base 2 number is 128. So if you're going to subtract this, 142 minus 128 is equal to 14. So as you can see that the next highest number just under 14 is 8. So what we're going to do is 14 minus 8 is equal to 6. Then look for the highest number, that is 6 minus 4 is equal to 2. Then you got put 4 there in up. Then 2 minus 2 is equals to 0. So you need to add the 128 plus 8 plus 4 plus 2 is equal to 142. And then, you can convert it into a binary number. So, 128 is gonna be 1. Then 64, since we have no 64, then definitely 0. Since 32 is, we don't have 32 and 16, so it's gonna be 0. Then we have also 8 and 4 and 2, so we're gonna put 1 there. So, we have also no 1, so that it's gonna be 0. So, the binary number of 142 is 10001110.
The next example is decimal to octal. How to convert a decimal number into an octal number. Example 394, which is in the base 10 system. How can we convert it into an octal number which is in the base 8? Well, the first thing we need to do is take the number that we have. So, 394 divided by 8 is equal to 49.25. The next we need to do is we need to identify the remainder. We have 49 remainder. In order to identify it, take the decimal value, then the numbers after the decimal point, that is 0.25, and then multiply it by 8. 8 times 0.5 is equal to 2. So we have 49 remainder 2. And now take the 49 and then divide it by 8. 49 divided by 8 is 6.125. So, this is going to be 6 remainder and then multiply 0.125 by 8. So, 8 times 0.125 is 1. So we have 6 remainder 1. Next, take the 6 and divide it by 8. Because 6 is less than 8, we could say that 8 goes into 6 0 times. With the remainder of 6, if we take the 6 divided by 8, it's going to give you 0.75. So this number get transferred here, and if you multiply the 0.75 by 8, it's going to give you 6. And now, the way you read your answer is to read it starting to most significant digit to least significant digit. So read the remainders from the bottom to the top. The first number is number 6. Then after that, we have an 1, and then we have a 2. And this is in a base 8 system. So 394 in the base 10 system is equal to 612 and a base 8 system. And that's how we can convert a decimal number into an octal number. Let's try another example. 784. The first thing we're going to do is we're going to take 784 and divide it by 8. 784 divided by 8 is equal to exactly 98. So this is 98, remainder is 0. Now, let's take 98 divided by 8 is equal to 12.25. So, this is 12, remainder, and then 25 times 8. 0.25 times 8 is 2. So, it's 12, remainder 2. Next, let's take this 12 and then divide it by 8. 12 divided by 8 is equal to 1.5. So this is 1 remainder, and then 8 times 0.5 is 4. So it's 1 remainder 4. Our next number is 1. So 1 divided by 8. So because 1 is less than 8, we can say that 8 goes into 1 0 times with a remainder of whatever this is. In this case, the remainder is 1. Next, we're going to read it from the bottom to the top. So, we have a 1, a 4, a 2, and A0. Therefore, 784 as a decimal is basically 1420 in the octave system. Let's move on to decimal to hexadecimal. Let's start with 479. How can we convert 479, which is a base 10 number that's a decimal number, into a hexadecimal number? How can we do this? The first step is to take the 479 and divide it by 16. 479 divided by 16 is equal to 29.9375. So, here we have an integer of 29, and then we need to find a remainder. To find a remainder, multiply 16 by 0.9375. So, 16 times 0.9375, that will give you a remainder of 15. Then, you start with this number 29 and divide that by 16. 29 divided by 16 is equal to 1.8125. That's one remainder. And to find the remainder, multiply 16 by 8125. And so, that will give you a remainder 13. And now, let's take 1 and divide it by that by 16. Now, we really don't need to do the division here because 1 does it go into 16. I mean 16 is going to 1, so we could say it's 0 remainder 1. But if you did it, let's say if you taken 1 when we multiplied 16.0625, it will give you 1. So, focus on these numbers 1, 13, and 15. I'm gonna rewrite it, but let me get rid of this stuff first. So we had 1, 13, and 15. So, the remainders, you want to convert them to hexadecimal numbers. 1 corresponds to 1, 13 corresponds to D, and 15 corresponds to F. Now, 1 is the most significant digit and F is the least significant digit. And now we need to write it in this order from the most significant digit to least significant. So therefore, digit. 479 in the base 10 system as a decimal is 1, DF as a hexadecimal. So we can write a subscript of 16 to indicate that this is a hexadecimal. So that's how you can convert a decimal number to a hexadecimal number. Now, let's try another example. 894. So, let's start with 894 divided by 16. 894 divided by 16 is equal to 55.875. That's gonna be 55 remainder, and take 0.875 and multiply it by 16. And that's gonna give you a remainder of 14. The next is, let's take 55 and divide it by it into 16. 55 divided by 16. 55 divided by 16 is equal to 3.4375. So, we have 3 remainder, and take the 0.4375 and multiply it into 16. And that will give you a remainder 7. And now, let's take 3. 3 divided by 16. That's gonna give us a number less than 1, so we can go straight to the answer, that's going to be 16, goes into 3 0 times, and with 3 remaining. If you do 3 over 16, you'll get 0.1875. And so, you have a 0 and then 0.1875 is going to be 3, so that's a remainder 03. So, let's convert the remainder values to hexadecimal values. So, 3 as a decimal number is 3 in the hexadecimal system. 7 is still 7. Now, 14 corresponds E, so we can write from the most significant digit to the least significant digit. 7E in the hexadecimal system, and so that it's for this example. Thank you. How to convert hexadecimal to binary number? So, let's start with this example, A9. A9, how can we convert that into a binary number? Well, the first thing we need to do is convert the A into a number or a decimal value in the hexadecimal system. A corresponds to 10, B corresponds to 11, C corresponds to 12, D corresponds to 13, E corresponds to 14, F corresponds to 15. So, we can replace A with 10. Now, each number and letter in the hexadecimal system, you can represent it with a binary number in groups of 4. So, A corresponds to 10 and we have 9. Now, how can we convert each of these numbers into a binary number? So, let's start with 9. So, let's use the numbers 8, 4, 2, and 1. 1 is basically 2 to the 0 power, 2 to the first power, 4 for the second squared, and 8 is 2 to the third power. 9 is the sum of 8 and 1. So we're gonna replace the 8 with A1. And because we didn't use the 4 in A, we're gonna substitute those of A0. We've used the 1, so we're gonna replace that before 1. Now, let's use the same pattern of numbers for 10. Now, 10 is the sum of 8 and 2. So, because we used those numbers, let's replace that with 4, 1. And we'll use a 0 to correspond with 4 and 1. Since we didn't use those numbers, so 10 is represented by the binary number 1010. 9 is represented the binary number 1001. Now, A9, this entire thing represents or is equivalent to this whole binary system. A sub 9 in the hexadecimal system, that is the base 16 system, is equal to this binary number 10101001. Basically, you can put this together. So, that's a quick and simple way to convert a hexadecimal number to binary number. In this video, I explain the basics of number systems and show you how to convert between binary, decimal, octal, and hexadecimal. Understanding these conversions is important in computer science, especially in programming and digital electronics. Thank you for watching. I hope this helped you understand number systems better.